Over 24 billion kilometers away from Earth, floating through the icy, silent void of interstellar space, glides Voyager 1. Its original mission ended decades ago. Most of its scientific instruments have long since gone dark. Yet, against all odds, its high-gain antenna is still pointed toward a tiny, pale yellow star in the distance, sending back faint whispers of data to the world that created it. Sometimes, those signals carry unexpected, even chilling revelations. But to understand what Voyager is telling us today, we have to look back at where it all began and retrace the greatest grand tour in human history. Our story starts in the late 1970s, powered by a rare celestial alignment that only happens once every 175 years. Jupiter, Saturn, Uranus, and Neptune all lined up on the same side of the Sun. This rare configuration opened a unique geometric shortcut. A single spacecraft could visit all 4 giant planets back to back, using the gravity of each world to slingshot itself to the next. NASA's budget was tight, forcing them to scale down a massive multi-probe mission into just 2 identical robotic explorers, Voyager 1 and Voyager 2. On August 20, 1977, Voyager 2 blasted off first, but almost immediately, disaster struck. As it cleared the atmosphere, onboard systems went haywire. The probe drifted off course, software began randomly shutting down systems, and controllers on Earth spent a frantic few days trying to prevent a total loss. Then came Voyager 1 on September 5th. Its rocket suffered a major fuel leak during ascent. The upper stage had to burn through nearly all of its emergency fuel reserves to compensate, reaching orbit with just 3.5 seconds of fuel to spare. Despite launching 2 weeks after its sister probe, Voyager 1 was put on a faster trajectory, overtaking Voyager 2 inside the asteroid belt. The race to the giant planets was on. By early 1979, Voyager 1 closed in on Jupiter. Cameras captured high-resolution, color images of a world dominated by violent turbulence, including the legendary Great Red Spot, a storm wider than Earth itself that had been raging for centuries. But the real shockers weren't on Jupiter, they were its moons. Astronomers expected dead, cratered ice rocks. Instead, Voyager found Io, a nightmare world locked in a gravitational tug-of-war with Jupiter, covered in active volcanoes blasting plumes of sulfur 500 kilometers into space. Europa, a world shrouded in a smooth, fractured crust of ice, hiding what scientists suspect is a global, liquid water ocean underneath. Ganymede and Callisto, massive, complex worlds with their own magnetic fields and mysterious ringed impact basins. Using Jupiter's immense gravity as an orbital slingshot, Voyager 1 hurtled toward Saturn, arriving in August 1980. Here, NASA faced a heartbreaking choice. Option A: send Voyager 1 on a risky, close flyby of Titan, Saturn's massive, smog-shrouded moon. Option B: skip Titan and keep Voyager 1 on course to explore Uranus and Neptune. Titan was too intriguing to pass up. NASA chose option A. Voyager 1 skimmed just 6,500 kilometers above Titan. Its optical cameras couldn't pierce the dense, orange haze, but its radio instruments revealed an incredible world, an atmosphere 1.5 times denser than Earth's, composed of nitrogen and methane, with surface temperatures dropping to minus 180 degrees Celsius. It was the first hard evidence that lakes of liquid hydrocarbons might exist on another world. Because of the maneuver required to reach Titan, Voyager 1 was thrown upward, out of the plane of the planets. Its planetary mission was over. The task of exploring Uranus and Neptune fell entirely on Voyager 2. Voyager 2 took up the torch alone. Arriving at Uranus in 1986, it discovered a weird asymmetric magnetic field, 11 new moons, and dark, thin ring systems. It also captured images of Miranda, a moon that looked like it had been shattered into pieces and glued back together, featuring sheer mountain scarps 5 to 7 times deeper than the Grand Canyon. In 1989, Voyager 2 reached Neptune. It revealed a vibrant, atmospheric world whipping with 2,000 kilometers per hour winds, marked by the Great Dark Spot storm, and orbited by Triton, a retrograde moon featuring active cryovolcanoes shooting liquid nitrogen ice 8 kilometers into its ultra-thin air. With their planetary flybys complete, both probes turned away from the Sun. At a distance of nearly 6 billion kilometers, mission controllers commanded Voyager 1 to turn its cameras around for one last look home. It captured a famous mosaic of the solar system, featuring a tiny bright speck suspended in a sunbeam, the pale blue dot. It had little scientific value, but profound human meaning. As Carl Sagan famously noted, every human who ever lived, every emotion, war, victory, and failure occurred on that single, fragile pixel of light. To prepare for deep space, NASA shut down the probe's cameras to save power, turning them blind. Driven by decaying plutonium-238 power sources, losing about 4 watts of power per year, every remaining watt was conserved for one final mission, finding the edge of our solar system. In 2012, Voyager 1 officially crossed the heliopause, the boundary where the solar wind gives way to the pressure of interstellar space. Voyager 2 followed in 2018. They had become the first human-made objects to leave the solar bubble behind. Today, Voyager 1 is over 170 astronomical units away, traveling outward at 61,000 kilometers per hour. Voyager 2 trails at roughly 142 astronomical units. With less than half their initial power remaining, engineers are constantly juggling onboard systems to keep communication alive. By the late 2020s or early 2030s, the generators will finally run dry. The probes will fall silent forever. In 300 years, they will reach the inner edge of the distant Oort cloud. In 40,000 years, Voyager 1 will pass near the star Gliese 445, while Voyager 2 passes near Ross 248. Stripped of power, deaf and blind, both probes will continue to drift through the Milky Way for millions, perhaps billions of years. Mounted on their sides are the famous golden records, carrying the sounds, images, and greetings of Earth to whoever might one day find them. They are no longer just robotic explorers. They are our eternal artifacts, wandering the cosmic ocean long after the pale blue dot has moved on.